Hello everybody, I start third, sixth lecture in the chemistry, in medical chemistry, and we continue with the intermolecular force. Intermolecular force is the attraction force between the molecules. Okay, we studied covalent bond, ionic bond, and metallic bond, which are between the atoms inside the molecule. But now we study intermolecular force, which attract force between the molecules. Okay. The energy is very lower than covalent, ionic, and metallic because they are usually between 100 and 1000 kilojoule per mole. But here we can see the energy is around 0 to the 40 kilojoule per mole. The type of intermolecular force we can divide in two groups, hydrogen bound and van der Waals force. Okay? And hydrogen bonding has a higher energy compared to the van der Waals. And the van der Waals force can be divided in two subgroups, dipole-dipole forces and London forces or dispersion force. Hydrogen bond is between the hydrogen of partially positively charged or polar hydrogen, okay, and pair electron of NOF, which are partially negative. It is very important. This hydrogen must be partially positive, this pair electron must be partially negative. For example, if we have this molecule C methane, we have a hydrogen with water, okay, this is exactly the hydrogen, it is a pair electron, but no hydrogen bond. Why? Because this hydrogen is not partially positive or polar hydrogen. It's very important. This hydrogen must be polar hydrogen. Okay? If the hydrogen is non-polar, hydrogen bond never can be formed. And it's very important also about this lecture. Negatively charged of NOF with the positively charged hydrogen atom. What I mentioned, or difference electronegativity between these two must be more than half. This is also polar hydrogen, okay, partially positive, and this pair electron also, this oxygen also the same. This hydrogen also partial positive, with this pair electron partial negative, they can be has a hydrogen bond. Hydrogen bond can affect the physical properties. Boiling point, melting point, solubility can be affected by the hydrogen bond. For example, in the group 6, we have element oxygen, sulfur, selenium, and tellurium. Okay? As you see here, one of the rules to increasing boiling point and the melting point is the molecular mass. It is very important. Boiling point and the melting point has a direct relationship with the molecular mass. For example, this 3 hasn't hydrogen bond. For example, H2O, H2S, H2SE, H2TE. Then, from here, we can say this accept this rule, okay? But hydrogen bond has a higher priority compared to the molecular mass, okay, mainly in oxygen. Because as you see here, water, because it has a hydrogen bond, then boiling point is so higher than all of these 3. Okay? For example, I give other example for group 4. Just they have a molecular mass, for example, this group. carbon, silicium, germanium, and lead. You see here? As you see here, increase the molecular mass and boiling point increased. But for the group 5, for example, nitrogen group, again like group 6, we have the same situation, but because electronegativity of nitrogen is lower than oxygen, and it is a weaker hydrogen bond compared to the oxygen, again it is high, but it is a little lower than SpH3. But for the hydrogen fluoride, which has a higher electronegativity, but because radius is smaller, in this case, the boiling point is increased, but not as usual as the water. But again, it is higher than these HCl, HBr, Hi. As you see here, these three accept this rule. Boiling point and the melting point is related or has a direct relation with the molecular mass, but the HF has a higher boiling point because of the hydrogen bond or because of intermolecular force. Then we can say with hydrogen bond, physical property, boiling point and melting point will be increased. For example, in the organic compound, alcohol and ether, they are isomer. As you see, it is a 1-butanol and diethyl ether, they are isomer. And the formula is this, that they have both has a 4 carbon and 10 hydrogen and 1 oxygen, okay? But this hydrogen is the polar hydrogen and it has a partial positive. Then easily can make a hydrogen bond with other pair electron of oxygen, other 1-butanol. But for the ether, these hydrogen are nonpolar. And cannot make a partial positive charge. Then usually not hydrogen bound or very, very weak hydrogen bound compared to the alcohol. Nothing, as you see, both have the same molecular mass, but boiling point in the 1-butanol is so higher than 1 diethyl ether. Also, hydrogen bound in organic compound also affect in the solubility, but molecular size and also polar and non-polar part is very important. For example, here is 1-butanol, solubility of 7.9. As you see here, it is a non-polar part, okay, it is a polar part. And if you see, the solubility is 7.9, but for the diethyl ether, again, because it can't produce hydrogen bond or very, very low hydrogen, weak hydrogen bond. In this case, we can say this one is a higher solubility. Or hydrogen bond, we can see hydrogen bond in the proteins, okay? In the secondary structure, alpha helix and the beta sheet. In the half helix, hydrogen bond can form between carbon and oxygen and the hydrogen of the nitrogen between amino acid 1 and amino acid 4. You see here, between the first amino acid and fourth amino acid. But in the beta sheet, it also is the secondary structure of the protein. Again, they are opposite each other, and the hydrogen bond will be between these groups, which are in front of each other, okay. If they're the same direction, it is a parallel. If the opposite direction, it is anti-parallel. Or we can say hydrogen bond we can see in the nucleic acid, in the DNA. In the DNA between A and T, adenine and adenosine and thymine, or guanine and cytosine, we can find the hydrogen bond. Between A and T, we have a double hydrogen bond, 2 hydrogen bond, and between the guanine and cytosine, we have a triple hydrogen bond, which is very important. and it is one of the important reason for the formation of DNA, because the DNA is a double helix, and because of the double strand can be formed because of these hydrogen bonds. Okay, if you see here between this inside, it is a hydrogen bond. If you see, I can draw again here. If you have it like this DNA, here will be hydrogen bond between the nucleic acid base. And we go to the van der Waals forces. The first one, dipole-dipole force. As you see, dipole-dipole is the dipole momentum is non-zero. The molecule is the polar, and it has a permanent dipole like HCl. If you see HCl with the other HCl can has the dipole-dipole force. It is between the partially positive charge of the part of the molecule with the partially negative part of the other molecule. Also, dipole-dipole increase the boiling point and the melting point. Dipole-dipole force, it is electrostatic attraction between the oppositely charged poles of the molecule. And as you see here in the HCl molecule, as I explained, between the partial negative chlorine and partial positive hydrogen, there is a dipole-dipole. Okay. And if we decrease temperature and increase the pressure, the order and it will be the orderity will be higher, the disorder decrease, and the molecule will be very nice order shape and very nice crystal in the solid form. And the last one of the second form of the van der Waals force is the London force, exists between any two molecules. Okay, it is usually happen when we increase pressure and decrease temperature, and we force the two atoms or molecules closer to each other. And in this case, a non-polar molecule or noble gas, we can say an example in this situation, become a small instantaneous dipole, okay, because they are close to each other. London force is a weak electrostatic attraction between the opposite charged pole, but in the instantaneous dipoles. For example, here no, if you see, it is alone. If we increase the pressure or decrease the temperature, we force they are close to each other. Okay, this area attract from the both nucleus, and become this part will be partial negative, other part will be partial positive, because again we have the same situation in the other molecule, and between partial positive and partial negative can be formed hydrogen bond. It is very easy. Excuse me, London force. Okay, for example, in the helium, usually simple helium has just symmetric molecule, symmetric atom, and it is very stable. But when we increase the pressure and decrease the temperature, we force the helium atoms to close each other, and we induce the formation of the London force, because we make atoms asymmetric, and one part of the helium will be partial positive and the other part will be partial negative. The partial positive has a low density of electron, and the partial negative high density of electron. It can be because of the force, because of the attraction between the electron with the two nucleus, and it is one of the important things. For example, if you see here iodine molecule, okay, it is a non-polar. Okay, as you see here, when in the solid form between it is a partial positive and partial negative, they make a London force between each other, and they are in solid force. But if you put iodine in the table, on the table, because it has a very good sublimation situation, it can convert iodine solid fastly to iodine gas because it has a London force, and with lower amount of the heat it can evaporate. I hope this lecture also very good, and I thank you very much for the pay attention, and I hope we can see each other in the next lecture and have a good time.